Greetings to all my tech heads out there in the KevTechify nation, and if you're new here, welcome. In this episode, we're going to look at mitigating VLAN attacks. We'll be discussing VLAN hopping attacks, VLAN double tagging attacks, mitigating VLAN hopping attacks, private VLANs, private VLAN edge features, and then finally configuring private VLAN edges. This episode is part of my series on network security. I'm Kevin here at KevTechify. Let's get this adventure started. All switch ports, all interfaces should be secured before you put that switch out into production. Now, how a port is secured depends upon its function. A simple method here that administrators use to help secure the network from unauthorized access is to disable all unused ports. Here, to disable it, you have to go into the interface itself. You can use the range command, so you can do a range. So we're doing a range of fast Ethernet 0 to 24. So interface range fast Ethernet 0/8-24, and that'll apply to all those fast Ethernet ports from 8 to 24. And then to disable that port, all you do is you type the shutdown. Right? Most of us know to activate the port, you go in there and type no shutdown. Well, now because it's not being used, let's go ahead and shut it down. And so that's a simple way to help secure your switches from unauthorized access. Port security limits the number of valid MAC addresses allowed on a port. It allows an administrator here to manually configure MAC addresses for a port or to permit the switch to dynamically learn a limited number of MAC addresses. When a port is configured with port security and it receives a frame, the source MAC address of that frame is compared to the list of source MAC addresses that were manually configured or dynamically learned on the port. By limiting the number of permitted MAC addresses on a port to 1, port security can be used here to control unauthorized access to the network. And what's happening here is you've either manually configured this or you let the switch dynamically learn one MAC address that's allowed on this port. And so port fast Ethernet 01 here, MAC addresses of all A's here, that's the allowed one. 2 is all B's, 3 is all C's. Now, when a device connects here into our port 1, it's going to look for that allowed MAC address. Is that the allowed MAC address? Yes, it is. We will allow that connection to go through. On port 2, the only allowed MAC address here is all B's. We're going to look at the MAC address of that computer connecting in on our F02 here. Is that an allowed MAC address? No. BAAD is not an allowed address, so we're not going to let this connection happen. Same thing here on fast Ethernet 03. We're going to look and see our allowed MAC address is all C's, and down here the MAC address trying to connect in is another bad MAC address, BAAD. And because that's not our allowed MAC address, we will not allow this connection to happen. The switch port security interface configuration command here for port security can only be configured on manually configured access ports or manually configured trunk ports. As a reminder, by default on layer 2 switches, ports are set to dynamic auto. They are set to trunking on, so dynamic auto. They have to either be manually set as an access port or manually set as a trunk. And right here in this example, you go into the interface. So right here, we're going into interface F01, and then we try to set the port security. Type in the command switch port security, and notice it gives us an error message. It says command rejected. Fast Ethernet 01 is dynamic. And so what we have to do is take it out of dynamic. How you do that is switch port mode access or switch port mode trunk. You're manually specifying what type of port. Now, once you specify switch port mode access, then you can apply switch port security. Once you've done that, you can go ahead and use the show port security interface command, and this will display the current port security settings for whatever port you're specifying. Here we're specifying Fast Ethernet 01. Notice that port security is enabled. So we have port security, it's enabled, and that port status is secure down. So port status is secure down, which means here there are no devices attached and no violation has occurred. Also, the violation mode is shut down. So the next line down here, violation mode is shut down. And the maximum number of MAC addresses allowed is 1. So right here we have MAC addresses allowed, and that is set to 1. To set the maximum number of MAC addresses allowed on a port, you use the command switch port security maximum, and then you give it a value. The switch port can be configured to learn about MAC addresses on a secure port in one of 3 ways. First way here is manually configured. When you do manually configured, the administrator manually configures a static MAC address by using the switch port security MAC address function. So switch port security MAC address, and then the MAC address of the device you want to allow to connect into that port. The second way here is dynamically learned. The command here is switch port security, and when this command's entered, the current source MAC address for the device that is connected to the port is automatically secured, but is not added to that startup configuration. So it's allowed to connect in, but it's not added to the startup config, so it has to learn every time you reboot, every time you start that new machine. Now, if that machine is rebooted, the port will have to relearn that device's MAC address. And the final method here is dynamically learned sticky. So it's very close to our dynamically learned, but now we add the sticky part here. And the administrator can enable the switch to dynamically learn the MAC address and stick them in the running config. So this part right here, this sticky. So looking at our command, switch port security, and then you say MAC address, sticky. This part sticky here puts it into the startup config, so when you reboot the device, that MAC address is set in there. If you like this episode on mitigating MAC table attacks and you get value out of it, and depending upon the platform you're using, please click that like button, give a 5-star rating, leave a comment, subscribe to my channel. Doing this supports the channel, which in turn helps me bring you more great content. You can also visit my website at KevTechify.com for all of my details and how to get these episodes in video and podcast form. Port security aging can be used to set the aging time for static and dynamic secure addresses on the port. Now, there are 2 types of agings that are supported on each of the ports. First one here is absolute. So absolute aging. The secure address on the port are deleted after a specified aging time. So after a certain time, X minutes, that MAC address is deleted. The other type of aging here is inactivity. The secure address on the port are deleted only if they're inactive for a specified period of time. So absolute, after so many minutes, regardless if it's active or inactive, it deletes that MAC address for that port. Inactivity waits until there's no activity going across the port, and then we specify a time, and after that time, then that MAC address is deleted from that port. What we do here is we use aging to remove secure MAC addresses on a secure port without manually deleting the existence of them. Normally, you'd have to manually go in there, remove those secure MAC addresses, but we can use aging to automatically delete those. Now, there's 4 types of aging. First one here is static. This enables aging for statically configured secure addresses on a port. Then we have the keyword time, and then you specify a time. Now, specifying the age time for this port, the range is from 0 to 1,440 minutes. If the time is 0, aging is disabled for that port. So if you never want those MAC addresses to age out, go ahead, you put a 0 in there. The third one here is type absolute. We set the absolute aging time here, and all the secure addresses on this port age out exactly after the time in minutes here specified, and then are removed from that secure address list. So after X minutes, it will remove them. And then finally, we have type inactivity. And once again, this sets the inactivity aging timer. The secure addresses on this port age out only if there's no data from traffic from the secure source address for that specified time period. And so we got to make sure that our device is sending data every so often, so that way it doesn't get deleted from our MAC address table. If the MAC address of a device that is attached to the port differs from the list of secure addresses, then a port violation happens. By default, a port enters the error disabled state. To set that port security violation, we use the command here, switch port security violation, and then you have a choice of 3 different security violation modes. First one we have here is protect. And this is the least secure of the security violations. The port drops packets with unknown MAC source addresses until you remove a sufficient number of secure addresses to drop below the maximum number or increase the maximum value. No syslog message is sent at this one. Then we have restrict here. Here, the port drops packets with unknown source addresses until you remove a sufficient number of secure MAC addresses to drop below that maximum value, or until you increase the maximum value of allowable MAC addresses. This mode causes the security violation counter to increment and generate a syslog message. And then finally, we have shutdown. The port here transitions to the error disabled state immediately. It turns off the port LED and sends a syslog message. It increments the violation counter, and when a secure port is in error disabled mode, an administrator must re-enable it by entering the shutdown command on that interface and then the no shutdown. So you have to go into that interface that has been shut down in error disabled mode. You have to go into that interface, you have to do a shutdown, give it a second, and then do a no shutdown. That gets rid of that error disabled. You manually, as the administrator, have to go in and do that. Here's the table that shows the security violation modes, and then we compare them together. Once again, we have our 3 security violation modes. Protect here, this was the least restrictive. Shutdown, that was the most restrictive. When these modes happen, first thing it'll do is it'll start discarding any of the offending traffic. So if it's not from the correct MAC addresses, it will discard it. It will delete. Yeah, we're deleting this traffic at this point in time. Then, do we send a syslog message? Once again, in the least protective one, we don't send it, but in the other 2, yes, we do send a syslog message. So that way, you set up a syslog server, you can get alerted to this. Now, does it increase the violation counter? There's a violation counter that tells you how many violations have occurred. When we do a violation mode here of protect, we don't increase it, but when we're in with restrict and shutdown, it will increase it there. And then the last one here, does it actually shut down the port? Well, protect mode and restrict mode, they do not shut down the port. If you want the port shut down, you have to use the violation mode of shutdown. That's the only mode that will actually shut that down. Here's an example of an administrator changing the security violation to restrict. Once again, you have to go into that interface. So we're going into interface F01, then it's switch port mode violation, and then we want to change it to restrict. And so we are changing it to restrict. We do a show port security for our F01. We can look down here and we can see that our violation mode is restrict. Now, previously it was protect. Now we are at restrict. What happens when the port security violation is set to shutdown and a port violation happens? So what we've done here, we went back into our fast Ethernet 01. We changed our violation mode here to shutdown. We went from restrict to shutdown now. Now, what happens when a violation occurs? That port gets physically shut down and placed in air disabled mode, and no traffic is sent or received on that port. Let's go through an example here and see what the feedback is. So on fast Ethernet 0, let's assume the first PC was connected in there. It learned it on port F01 here, learned that MAC address. And then now let's take and put a new PC, a new MAC address plugged into that port. And what we can see here is the line protocol changed it to down. So you unplug the cable here. The protocol went down, the interface went down. Now we're going to plug in a new device. So right here, we've plugged in a new device. Line protocol is changed to up. But when it examines that MAC address, it sees that it's a new MAC address, and we're only set to know one MAC address. It causes that violation of shutdown. That's what we just set up here. We set that violation of shutdown. Because it's not that first MAC address that the device learned, it's a second MAC address, and we're only set to learn one MAC address. We go into air disabled mode. So you can see we are going into air disabled mode. We're staying on F01, and now we've set it to air disabled mode. Gives you some more feedback. Security violation occurred. It was caused by this MAC address. And once again, this MAC address is not the first one. It's the second one that tried to connect in that caused the violation. And once again, just telling us what port that was on. Now, because the violation mode here is shut down again, the line protocol is going to be changed to down, and the actual interface is going to be physically shut down. It's now in air disabled mode. And remember, how do you get it out of air disabled mode? You go into that interface. So you have to go into interface FA01. You have to shut it down. So you have to do a shutdown on it, and then you have to re-enable it. You have to do a no shutdown. That will get it out of air disabled mode. After configuring port security on a switch, you have to check each interface to verify that port security is set correctly. And you also need to check to ensure that any static MAC addresses have been set correctly. To display the port settings for the switch, we can use the show port security command. We can also use the show port security interface command to view the details of a specific interface. To verify MAC addresses are sticking, remember how we talked about when you plug in a MAC address, plug in a port, plug a cable computer into a port, it will forget it unless you use the sticky command. Now, to make sure that those addresses are sticking, we use the show run command, and it will list out all of your sticky addresses. Finally, to show all secure MAC addresses that are manually configured or dynamically learned on your switch interfaces, we can use the show port security address command. The MAC address notification feature sends SNMP, Simple Network Management Protocol, SNMP traps to the Network Management Station, NMS, that's where all those SNMP messages get collected, whenever a new MAC address is added to or an old address is deleted from our forwarding tables. MAC address notifications are generated only for dynamic and secure MAC addresses. And we want to use the MAC address table notification command here to enable the MAC address notification feature on a switch. It was my pleasure to provide you with this wonderful episode on mitigating MAC table attacks. If you like this episode and you got value out of it, and of course, depending upon what platform you're using, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All of my socials and contact information are on my website, KevTechify.com, and you can get all these episodes in video and podcast form. In the upper right is my playlist for my series on network security. In the bottom right is one of my videos I think you'll really like. Thank you so much for watching this episode of my series on network security. Once again, I'm Kevin. This here is KevTechify. I'll see you next time for another great adventure.